Hello everyone, welcome to StudyIQ. So in the previous video on ratio, we have seen the basic concepts and we have seen the important properties related to ratios from which you can get questions directly, right? So in this session, we will see some of the mathematical uses of ratio. From that also you'll get direct questions, okay? So let's look at the first possibility. Ratio as a bridge between three or more quantities, okay? So as a bridge, okay? Ratio as a bridge between three or more quantities. It's like you will get a relationship between A and B, you'll get a ratio, say something like salaries, okay? So the ratio of salaries between A and B, like A and B, okay? Then you will get the ratio of salary between B and C, okay? Then you will get questions like A and C. What is this? So how will you solve this kind of question is what we are going to look at here, okay? Now here the idea is basically you got these two ratios, so you can combine these two ratios and you can come up with a consolidated ratio, that is A is to B is to C, and from that you can pick A and C. That's the idea. But how will you do that? The conventional method is by taking the common thing which is involved here, that is B, right? So two B values you will have and take LCM, and based on LCM make the necessary changes, right? So that's the conventional approach. So okay, if you want to know that, see, let's take one example. The ratio between A and B is given as 2:3, okay, or 1:2 or 1:3 or whatever you want, you can take. So it's between the salary, okay? So A salary and B salary, the ratio is given as 2:3. It can be 2,000, 3,000, 2 lakh, 3 lakh, 4 lakh, 6 lakh, or whatever it is, right? And then what is given? B to C. So B to C is given as 4:5, okay? So this ratio is given and you're asked to find out A is to C, okay? So now you may ask to find out the ratio, or like what we have seen in case of mixtures and alligation, where in case of mixtures and alligation you will get the ratio when you do that cross thing, right? And then one of them will be given, like A will be given as, let's say, something like 800, okay? So A salary is given as 800, and then they will ask you C salary, they will not ask you ratio. So I hope you understood this question. The ratio of A salary and B salary is given 2:3, okay, and then ratio of B and C is given 4:5. Then the question is, if the salary of A is 800, what will be the salary of C? Okay, so basically you need to find the ratio of A and C, or you need to find A is to B is to C. Then from that you know A, so you can get C. This idea. Now how will you come at this relation? See, what is common here? If you look at this, the common thing is basically B, right? So what is common if I ask you? That is B. So the conventional approach would be take LCM of two B values. So 3 and 4 are the B values. So I'll get LCM of B as 12. Okay. Then what I need to do is keep this B as 12 and keep this B as 12. So to keep the first one as 12, what you need to do is multiply with 4. So you need to multiply the other also with the 4, right? See, you can also write this as, A by B is equal to 2 by 3 and B by C is equal to 4 by 5, okay? So what you need to do is you need to convert this to 12, okay? So now how will you convert that? How will you do that? You will multiply here with 4. So numerator also you'll multiply with 4. So what you will get is 8 by 12. Okay. So A by B you get it as 8 by 12. Similarly, here you will convert this 4 to 12. So you'll multiply with 3 here. So that change you need to make in the denominator also. So what you get is numerator is 12 and denominator will be 15. So this you will get as 15. Now if you look here, B is same because you have taken LCM. So now you can write A is to B is to C as 8 is to 12 is to 15. Now from here you can write A is to C as 8 is to 15, or A by C is equal to 8 by 15, or A is to C is equal to 8 is to 15. Now what is given in the question, it is not the ratio which is asked. They are saying that 800 is the salary of A. So 8 stands for 800. So 15 will stand for 1500. Okay, so what is the answer for this question? 1500. So the two questions possible is either they will ask you this ratio or they will ask you the ratio of all the three together like this, okay. This is also possible, or this is also possible, or they will give you salary of one, that is A, and you need to find the other, okay. So this is what the first application. Now here we have seen three quantities, and it's easy to use LCM, but if you have more than three quantities, taking LCM and equating it will be slightly difficult, right? So in that case, I'll give you a shortcut. See, let's suppose you have 4 ratio, A is to B is given, okay. Let's take it as 2 is to 3, then B is to C is 4 is to 5, okay. C is to D is there, that is 6 is to 11, then D is to E is 12 is to 17. This is given, okay. So you have 4 ratio or 4 fractions if you write 2 by 3, 4 by 5, 6 by 11 and 12 by 17. Now if you're asked to find out A is to B is to C is to D is to E, or any of this, A is to D or A is to C or A is to E or A is to B, what you need to do is like this. This A you can write as, okay, I will generalize it later. Take the product of all the numerator. See, if you write it as fraction, it's like 2 by 3, then 4 by 5, then 6 by 11, then 12 by 17. So this is how you'll write as fraction, right? So all the numerators is what your A. That means 2 into 4 into 6 into 12. Okay. So is 2. Then if you need to know B, take the first numerator, take the first denominator. Okay. Then 3 numerators. First denominator and 3 numerators. So it will be 3 into 4 into 6 into 12. Why you are doing this, I tell you. Okay. Then after that you need to find C, right? So for that you take this 2 denominator and 2 numerator. So what it will be? 3 into 5 into 6 into 12. Okay. Now to find B, you take 3. Now follow the same order now. You take 3 numerator and 1 denominator. So that will become 3 into 5 into 11 into 12. Now to find E, you take all the 4 denominators. Okay. So 3 into 5 into 11 into 17. So we started off with 4 numerator. We ending with 4 denominator. In between what we are doing, this is the first numerator. Now this is the first denominator and 3 numerator. Then 2 numerator, 2 denominator, 3, then 2 denominator and 2 numerator, then 3 denominator and 1 numerator, then 4 denominator. Okay. So let me tell you once again. 4 numerator, 1 denominator, 3 numerator, 2 numerator, 2 denominator, 3 denominator and 1 numerator, and 4 denominators. So denominators will increase. Here 1 denominator, 2 denominator, 3 denominator, 4 denominator. Okay. So if you generalize this, now if you can generalize this like what we have seen in the previous session, you have A by B, you can write as N1 D1 because you have a numerator and a denominator. Okay. Now B by C you can write as N2 D2, and C by D you will write as N3 D3, and D by E you will write as N4 D4. See, this N means numerator, D means denominator. All 4 numerators and 4 denominators is what we have written here. Now what we need is, we need to write the ratio A, B, C, D, E, right? So this is what we need to do. So the first one, A, how will you write? I told you already, all the 4 numerators, N1, N2, N3, N4. Just multiply all the 4. Now B, how will you write? First denominator, that is D1, then all the numerators, okay, N2, N3, N4. Now how will you write C? First 2 denominators, okay, so D1, D2, N3, N4. Now D, how will you write? 3 denominators, so it will become D1, D2, D3 and N4. Now E, how will you write? All 4 denominators, D1, D2, D3, D4. So this is how you will write if you have more than 3, and you can continue this, right? So I hope all of you understood how I am writing this, right? Now next use of ratio is basically ratio as multiplier. Okay, ratio as multiplier. Now what does this mean? See, if a ratio is given A is to B is equal to 3 is to 1. Okay, so A is to B is given as 3 is to 1. Now in this case, what you need to do is the value of B has to be multiplied by 3 to get value of A. So very simple. See, if you know value of B, to get A, just multiply with 3, so that you will get it. Cross multiplication, that's what we have seen, right? So that's what ratio as multiplier. Now you can see now we'll see some calculation methods. Okay, we'll see some of the calculation methods for ratio comparison. Okay, see some questions you will get like numerator is increased in the ratio, okay, or the denominator is increased, or numerator and denominator increased, or numerator is decreased, or numerator and denominator is decreased. See, the possible cases are, see, let's suppose numerator, okay, and denominator, then you can write ratio. Okay, so let's see what are the possible cases. 4 possible cases will be like this: numerator increase and denominator decrease. Okay, see, if numerator increase, denominator remain the same, means there is no possibility of asking question, because that is directly proportional. Numerator is directly proportional with the ratio, so the ratio will also increase. Similarly, if numerator no change and denominator increase, we know ratio will decrease, and vice versa. If denominator decrease, ratio will increase. If numerator decrease, ratio will decrease. We know that. Okay, so numerator is directly proportional with the ratio and denominator is inversely proportional with the ratio. So any change we can find accordingly. So there is no possibility of questions directly, but the possibility is like this: numerator and denominator changed. Okay, so let's see first possibility: numerator increase, denominator decrease. What will happen with the ratio? Ratio will always increase. Okay, ratio will always increase, because see, just imagine this situation: denominator is fixed, nothing happened. Numerator increased, ratio will increase. Now what we are saying is, even if there is no change in the denominator, ratio will increase. So what if the denominator decrease? 100% sure that the ratio will increase. Now forget about this. Okay, forget about this. Just take the situation where the denominator is decreased, still ratio will increase without any change in numerator. But here numerator is increased, so ratio will increase. You don't want to do any calculation here. What is the second possibility? Numerator will decrease, denominator will increase. So here the ratio will always decrease. Numerator decreased. Now keep the denominator as such. No, don't think that decreased or increased. Okay, so if numerator decreased, the relationship between ratio and numerator is directly proportional, right? So when numerator is decreased, then itself ratio is decreased. Forget about any increase in denominator. Now what if increase is there in the denominator? Obviously there will be a decrease in the ratio. Now keep this as fixed. Okay, no, don't think that there is a change in numerator. Even if the denominator is increased, the ratio will decrease. I hope this is clear. What is the next possibility? Numerator increase, denominator increase. Now we cannot conclusively say ratio is increased or decreased. We need to do calculation here. Okay, see, without doing calculation you can't say, because this property that we have already discussed, right? See, numerator may be increased by 10%, but denominator may be increased by 20%. Then the ratio will come down. And if the opposite happened, numerator increased by 20% and denominator increased by 10%, then the ratio may increase, and that too depends on number and the respective percentage of the number. See, if you remember in the previous video we have discussed this case 50 by 80, and you write it as 55 by 88, there is no change, because the effective increase is actually 5 and 8, right? These two are actually same, so there is no change. So if numerator, the increase in numerator and increase in denominator, if it is equal, there is no change. Okay, but this ratio, increase in numerator to the increase in denominator ratio, if it is less than the original ratio, then there will be a decrease in the ratio. If it is greater, then there will be an increase in the ratio. We have seen this property, and same is the case here also. Both decreased. If both decreased, may or may not increase, or it can be increase or decrease. Okay, we need to calculate. We need to know the exact situation. Now in some questions you are asked to find the bigger ratio, or you are asked to compare the ratio. Okay, so in such situations one of the method that we used to use is actually cross multiplication method, right? Cross multiplication method. See, let's suppose you have two ratios, 12 by 17 and 15 by 19. So if you need to compare this, you can use cross multiplication method. And how you do that? See, basically what you need to do is 12 into 19 you do, and 15 into 17 you do. Okay, now 12 into 19 and 15 into 17. See which one among this is largest. if 12 by 19 is larger in this, then the ratio 12 by 17 is high or larger. If 15 by 17 is larger, then the ratio 15 by 19 is higher. I hope this is clear. So just do the cross multiplication and see which one is the largest. Now in this case, if you see, 15 by 17 is the larger. So obviously this ratio is the highest one. Okay, so what you need to do is just cross multiply, see which one is larger. So if 12 into 19 is larger, and it depends on the numerator. If this is okay, so if this is larger, this is larger. If this is larger, and then this is larger. See, but in real cases, it may be very difficult to you do this cross multiplication, right? If you get some bigger number, finding the product itself will be difficult, and instead you can find percentage, right? See, let's suppose you get some values like 173 by 212 and 181 by 241. Okay, so if this kind of values, cross multiplication is difficult. So what you can do is you can find the percentage. So by looking into this, you can understand that this first ratio is greater than 80%. So you need to have some more idea about percentage that we have already discussed. So the first ratio is greater than 80%, second ratio is less than 80%. Okay, so obviously you can mark this as the largest one. Now sometimes you will get both in 80s range, then you will proceed, then you need to proceed further. Okay, and the most effective method to compare the ratios actually by using numerator and denominator percentage change method. So two methods that we have discussed is cross multiplication method and percentage value comparison method. Third that we are going to discuss is, or this is what we are actually going to use when you are solving questions in CAT. Okay, because see, numerator denominator percentage change method, you need to see what is the change in numerator, you need to see what is the change in denominator. Okay, in terms of percentage. So let's take the same numbers, 173 by 212 and 181 by 225. Okay, so here you can see there is a change in the numerator, there is a change in the denominator. Let's see 173 to 181, what percentage change is there? So this is actually 4 to 5 percentage. Okay, so change is around 4 to 5 percentage. Now if you look here, why? Because 173 to 81, what is the change? That is 8 divided by 173 into 100. Okay, now here what is the change? 6 to 7. Okay, you don't want to know exact value. 6 to 7 is there, which is greater than 5. That's enough. So if you see here, the denominator is increasing more than numerator. So if denominator is increasing more than numerator, means the second ratio is the smaller one. Okay, so which one is higher? The first is higher, because if you see the change in denominator changes more. Now what if it is the opposite? If you see more change in numerator, then this ratio will be the higher. So I hope this is clear for you, and this method is very, very useful. So any two ratios, if you see the percentage change in numerator, see the percentage change in the denominator, and see where is higher. If denominator is changed more, then the first ratio is higher. If the numerator changes more, then the second ratio is higher. Now I give you another method also to calculate value of percentage change in the ratio. Let's take 2%. That is 50 by 70, okay, and 55 by 84. So if you look here, numerator what percentage change? 10% change. Denominator what percentage change? 20% change. Okay, so 70 to 84. We know the factor of multiplication is 1.2. 1.2 minus 1.2. Shift 2 places, it becomes 20. Okay, so we know 10 and 20% changes there respectively in the numerator and the denominator. So here, let's take this as the original ratio, okay, and this is a final ratio. So effectively how we are getting this final ratio? Original ratio minus, or original ratio, and then you can add the effect on the numerator, because there is a 10% change, right? So effect on the numerator, that is 10% change in the numerator effect, you get an intermediate ratio. And here if you take the effect on denominator, so 20% effect on denominator, you get the final ratio. This is the process that we have done. And if you remember, why I have shown you in this way is basically because we have discussed PCG rule when we discussed about percentage chapter, right? So that's what you can apply here. And in fact, this also related to product constancy rule that we have discussed. So this is going to be very easy for you to understand. See, the percentage change you can calculate like this. So what we have said is 50 by 70, which is changed to 55 by 84. and we know this is 10% and we know this is 20%. Okay, so we need to calculate the effective change in the ratio. So you can assume that 100% in the beginning. Okay, then assume that this is the original, so I am taking it as 100 when we calculate in terms of percentage. So effect of numerator, that is 10% increase. So you'll get an intermediate value, right? Intermediate ratio. So what will be that? That is 110. Then effect on denominator, that is 20% decrease, right? So 20% decrease from 11, 110. So 10% of 110 is 11. So 20% means 22. So when you subtract 22 from 110, you get 88. Okay. So if you see effective change, so this is your first ratio, this is your second ratio. So from 100 to 88, what is the percentage change? Minus 12. So 12% decrease in the ratio. So this is how you can calculate percentage change in the ratio. Okay. So effect of numerator is given 10% and effect of denominator 20%. Okay. So effective change in the ratio is like this. Now the same is what we are going to use, right? Or if you take another example, 20 by 40 becomes 22 by 50. So if you see the change here is 10% and the change here is 25%. Okay. So how will you understand the percentage change? So 100, that is the original ratio, that becomes an intermediate ratio. We'll see what is the intermediate ratio because of the effect of numerator. That is 10% increase. That means 110. Then there is a 25% decrease, that is a denominator effect, that will lead to 82.5. So what is the change? 17.5% decrease in the ratio. I hope this is clear for all of you.